We now look at the idea of a composite function. And rather than defining a composite function, I'm going to give you an example. Your book does a good job of defining it. Let's take the function f of x equals e to the x squared. This function is really built from two functions. We start with x and we square it, and then we apply the exponential function to that squared value. We could represent this by saying, okay, g of x equals e to the x. Now, g of what equals e to the x squared? Well, it should be clear that if we plug in x squared where this question mark is, that's what we're going to get over here, because the question mark replaces x, and we want x to be replaced by x squared. So we would say that g of x squared equals e to the x squared for this function g of x. And if you understand function notation, that's a very straightforward idea. We then say h of x equals x squared. We just give x squared a name, h of x. And once we've given x squared a name, h of x, then this g of x squared becomes g of h of x. And we write g of h of x equals e raised to the h of x, because of course g of x equals e to the x, g of h of x is going to equal e to the h of x. Since h of x equals x squared, we got e to the x squared. We say that e to the x squared is a composite of the function h of x and g of x. And I've lost my train of thought, excuse me. E to the x squared is a composite of g of x and h of x. And I'll just say it's extremely important to be able to see how a function is built up as a composite. Your text will give you more information, more details, more examples, but this whole idea of a composite function is extremely important when you take derivatives. Okay? X squared has a simple derivative, 2x. It's a quadratic. E to the x, as I've told you, has a simple derivative that's just e to the x. What in the world is the derivative of e to the x squared going to be? Well, in order to understand the answer to that, we have to develop some machinery for taking derivatives of composite functions, because that's what we've got, and we will want to take the derivative of such a function. That's a topic that we'll get into in another month or so. For now, you should understand how important it is for you to do a good job with composite functions and to really understand what you're doing with composite functions.